Today we're going to look at the law of cosines, which again you probably have done before. The law of cosines is used when you don't have the right triangle, because we'd be doing SOHCAHTOA then, and when you're not given the right information to do the law of sines. Remember, for the law of sines to work, you have to have matching letters. Law of cosines is used when you don't have matching letters. This right here is the law of cosines, and there's about 6 different versions of it probably put in your textbook. We're just going to remember kind of this and understand the pattern of this. Basically, they're saying if you take a side and square it, it should be equal to the other two sides squared, added together, subtract 2 times those same two sides, times the cosine, thus the law of cosines, of the angle that matches the side you're looking for. Now, this is not always going to be the exact formula you use. You might instead need to be using the formula that goes b squared equals, and then you'd be using the other two letters, a squared plus c squared, minus 2 times those same two letters, a and c, times the cosine of the letter that matches what you're looking for, so in this case it's cosine b. Alright, I would probably suggest you go ahead and write that, and then go ahead and write what's the third one. What would it be? I'll give you a hint. It's going to start off c squared, and then you finish it out. Now, moving on, again, most of the time you're going to jump in, you're going to do law of cosines, and everything's going to work beautifully. There's one quirky thing that you have to worry about when you're doing the law of cosines. And we typically, it's a little bit lengthier of a formula, so we're only going to use it once to find one piece of missing information. That missing piece of information is going to allow us to revert back and do the law of sines, because we'll have a matching set of letters at that point. Now, what is the missing piece of information that we should get using the law of cosines? Well, sometimes it doesn't matter. Sometimes you just use what you can. There's one thing, though, that you have to recall, and that is that the law of sines will not ever find an obtuse angle for you. Do you remember why? Okay, nice little refresher from earlier when we were doing trig in chapter 4. Okay, think about how you're finding your angles. You do second sine. Second sine is the inverse sine. Recall that inverse sine always pulls or always gives you an answer from these two quadrants. And the angles that are down here are actually negative angles, so we definitely don't want those. The law of sines, when you do second sine, is only going to give you acute angles. However, the law of cosines, you'll be doing inverse cosine, and inverse cosine pulls from these two quadrants. The inverse cosine will get you acute angles, but will also get you obtuse angles. Which is why in red I have here that you're going to use, and you want to highlight this in your notes or do something, use the law of cosines to find any potential obtuse angles. Not every triangle is obtuse, but if there's going to be an obtuse angle, you want to be using the law of cosines to find it. Then you can go do the law of sines, because it won't matter after that. It can only have one obtuse angle. The alternative would be to possibly go ahead and find any angle, but wait until the very, very end to find your obtuse angle by subtracting from 180. The big key is that if there's going to be an obtuse angle, do not use it using sine. Do not find it by using sine. That's the big thing. It's not going to give you the right number. Let's try one. Here we go. Notice that I do not have matching letters. That's going to be my clue. I need to do law of cosines. Now, as far as find the obtuse angle first, well, you look at your three sides, and whichever side is the biggest, that's going to be the angle, that's going to be the side across from the biggest angle. If this was going to be an obtuse triangle, angle C would have to be the obtuse angle. What that means is I want to be doing the law of cosines to find angle C. That kind of clues me into which of those formulas I should be using. I'm going to want it to say cosine c out at the end, which means I'm going to start with c squared. Remember that that's equal to the other two legs squared minus 2 times those same two legs times the cosine of angle C, which if there's going to be an obtuse angle, it's going to be angle C. Here we go. Let's start filling in numbers. 18 squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of C. Be really careful right here that you pay attention to your order of operations. These things here are being multiplied by the cosine of C. Don't try to attach this to this stuff over here. You want to go ahead and move these two things over. I'm going to subtract 100. I'm going to subtract 144 over on this side. So basically I'm subtracting 244 from 18 squared. So let's type that in our calculator. Just do 18 squared minus the 100 and minus the 144. And you get an 80. Equals, and then all this other stuff is still sitting here. All of this. And it's negative. I'm probably going to go ahead and say it's a negative 2 times 10 times 12. That'd be negative 240. Cosine C. Divide both sides by negative 240. And it's a 1/3, it's a negative 1/3, but I need the value in my calculator so that I can do second cosine second answer. And I get an, oops, I'm in the wrong mode. Hang on. I get an angle measure of 109.470. Look at there. That is an obtuse angle. It's a good thing I did law of cosines to find it. Law of sines would not have found that for me. That's angle C. Let's go find another angle. Doesn't really matter which one. But remember that we use the law of cosines once, and then we go do the law of sines to finish it up. I've got matching letters now. 18 over the sine of 109.47 equals, I guess I'm going to go find A. So let's do 10 over the sine of angle A. Do your cross products. Now I'm going to be dividing that by 18. But what I have left, remember, I have a 0.523 or 524. But that's the sine of A. You got to do second sine on that. And I get an angle A of 31.59. Find angle B by subtracting those two angles from 180. And it looks like angle B would be a 38.94. All right, there's your law of cosines for you. Here's a second example. It's a different scenario because what's going on here, well, I'm giving you different things. The last time I gave you side, side, side. That's not what I'm giving you here. I have two sides and an angle. This is actually not angle side side though because I don't have matching letters. This is actually a side angle side. But since I don't have matching letters, I can't do law of sines. That means I'm going to be doing law of cosines. In this scenario, I don't really have much option as far as which one to look for first. They give me angle C. I have to use the formula that uses angle C. That's going to be a C squared equals A squared plus B squared minus 2AB cosine of angle C. I have to use this one because that's what they gave me. Little c squared is what I'm looking for. A squared is going to be 36 plus 100 minus 2 times 6 times 10 times the cosine of 75. Notice that I have absolutely everything on this side of the equation. When that happens, it works out beautifully. Just enter it in your calculator, left to right. Don't press enter anywhere in there. You're just going to take 36 plus 100 minus 2 times 6 times 10 times cosine of 75. And right there, c squared is 104.94. And then you have to square root that, because what you really want is c. Now I have the missing side. If you look at this, remember we only do law of cosines once, really, and looking at what I have, of my 3 side lengths, side C is the longest, which means angle C, if there were going to be an obtuse angle, it would be angle C. Angle C is not obtuse. I don't have to worry about any obtuse angle stuff anymore. I'm just going to jump in, do my law of sines. I'm not going to worry about whether it's the obtuse angle or not, because apparently this triangle does not have one. Let's go find an angle measurement. I've got matching C's now. I'm going to use 10.24 over the sine of 75 equals, I guess I'm going to go with my A's, 6 over the sine of A. You're going to do your cross products. You're going to divide by the sine of 75. I'm sorry, undo that. Nope. Cross products this way, because that's the stuff you know. You have to multiply the things you know. Divide by the 10.24, and what you're left with is the sine of A. In my calculator, 6 times sine 75. Close the parenthesis, divided by the 10.24. What I'm looking at, though, is actually the sine of A. I'm going to do second sine, second answer. And angle A is 34.47. The only thing missing is angle B. And the easiest way to find that is to subtract the 2 angles that I know from 180. I get 70.53. Got my 3 missing parts. Those 2 examples that I gave you were kind of the only things that are going to be given to you, either side, 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 or it's a side, angle, side. I'm not going to do a bunch of examples of those. Let's try one other thing, one other formula. Just like earlier in Law of Sines, we had an area formula that worked nicely for the information they give you for Law of Sines. We also have an area formula that works nicely when you have information for Law of Cosines. Specifically, Heron's formula works if you know side, side, side. Which is kind of interesting because, again, when you're looking for the area of a triangle, you always had to, in middle school, you had to drop the altitude and do 1/2 base times height. But this works great if you just know all the side measurements in a triangle. It's very slick. Why did they teach you that in middle school? Here's the formula. It's a little bit lengthier of a formula, but it's pretty easy to use. What you have to know is the perimeter of your triangle. And if you take 1/2 of your perimeter, we're going to assign that a value called S. That's half the perimeter. And then in the formula, you're basically taking the square root of half that perimeter times, and then you're going to take that half perimeter and subtract each of the sides of your triangle. You multiply that all together, square root, boom, you got your area. Let's try. First thing, let's find the perimeter. We got a 7, a 4, and a 10. That's a perimeter of 21, which means if the perimeter is 21, then S is 10.5. and we're going to use that measurement there. The area equals big square root the 10.5 times, and then you're going to take the 10.5 and subtract each side. 10.5 minus 7. 10.5 minus 4. 10.5 minus 10. And we just type that all in our calculator. So I'm going to do the square root. 10.5 times 3.5 times 6.5 times 0.5. And the square root of all of that is 10.93, and since it's area, we label it units squared. Nice quick formula. Heron's formula. Works great with side, side, side. The one last thing that I did want to remind you of is that triangle inequality theorem. I mentioned it in the previous video, but let's talk about it again. In geometry, this goes back to geometry, you have to remember the triangle inequality theorem that says that the two shorter legs in a triangle have to add up to be more than this long leg. If you look at this example, 4 plus 2 is 6. That's smaller than 7. If you go ahead and bring this thing down and bring this one down, those two sides are never going to touch. That cannot form a triangle. But if these two sides add up to be longer than that third side, so 4 and 5 is 9, that's bigger than 7, then they will touch and they can form a triangle. I think probably in geometry they wrote it something like A plus B has to be greater than C, where C is well, it really didn't even matter which side was the longest or shortest. Just make sure any two sides add up to be longer than the other side. On your homework, they're going to throw some of those at you out of the blue, that they don't even create a triangle. So kind of check that. If they're giving you side, 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 check to make sure that your two smaller sides add up to be bigger than your third side, because if it doesn't, you're just going to write no triangle and you're going to be done and there's no more work for you. Be looking for it. Good luck.